Today we're on lesson 18 of Unit 10. We'll be covering pages 331 to 333. You want to have your calculator and a highlighter. Solving equations containing radicals. The steps in solving an equation containing radical. Isolate the radical. That is extremely important. That radical needs to be by itself. And then if it's a square root, we square both sides. If it's cube root, we cube both sides. Solve the resulting equation, and then you must check in the original equation. Must check. Beware, squaring both sides sometimes produces an extraneous solution. That is why we have to check back into the original equation. Always check back into the original equation, the solutions you get. Okay, now there's quite a few problems, so I'm going to start with some selected ones, and then if there's time, we'll go back to any ones that we skipped. So starting with B, we have the square root of 5x equals 10. Well, the radical is already by itself, so we simply square both sides. And squaring a square root removes the square root symbol. 5x equals 100. Divide by 5. X equals 20. Checking that, you can use the calculator if you want. I think it's simple enough. Is the square root of 5 times 20 equal to 10? That's square root of 100, 10. Yes, 10 equals 10. It does check. C, we have to isolate the square root of 4x. So first subtract 2 from both sides. We have the square root of 4x equals 6. And now we square both sides. Four x equals 36. Divide by 4, x equals 9. Check. Does the square root of 4 times 9 plus 2 equals 8? 4 times 9 is 36. The square root of 36 is 6. 6 plus 2 is 8. 8 equals 8. It does check. D, 7 plus the square root of 3x equals 1. Isolate the square root of 3x. We'll subtract 7 from both sides. Square root of 3x equals negative 6. Square both sides. 3x equals 36. Divide by 3, x equals 12. Check. Does 7 plus the square root of 3 times 12 equal 1? 7 plus 3 times 12 is 36. The square root is 6. 13 equals 1? No. So there's no solution. This is extraneous. Some of you may have seen that before. We even squared both sides. The square root of what is going to result in a negative 6? There is no number. If you take its square root, it would result in a negative value. E, we have cube root, right? And our cube root is isolated. It is by itself, so we raise both sides to the power of 3. That removes the cube root on the left-hand side. We have 5x plus 75 equals 125. Subtract 75. Leaves us with 50. Divide by 5. X is 10. Checking it. Is the cube root of 5 times 10 plus 75 equal to 5? That's 50 plus 75 is 125. The cube root of 125 is 5. That checks. If there's a coefficient with the radical, square or cube the coefficient also. Looking at G, we have 3x equals 2 times the square root of 3x minus 1. So in this case, leave the coefficient 2 with the square root where it is, and square both sides. 3x times 3x is 9x squared. Now, don't forget to square the 2, right? We're distributing here. So this is 2 squared, which is 4, and then the square root of 3x minus 1 squared removes the square root. Make sure you put the 3x minus 1 in parentheses because we do have to distribute the 4 over that parentheses. Now it's quadratic, so standard form, 9x squared on the left-hand side. 9 is positive there, keep it there. Bring the 12x minus 4 over to the other side. So subtract 12x and add 4. It's in standard form. I'll try factoring with rainbow first, right? 9 times 4 is 36. Factors of 36, that sum to negative 12, negative 6, and negative 6. So we have 9x squared minus 6x minus 6x plus 4. We split. GCF 3x, 3x minus 2. Should go over to here. GCF 3x. You get 3x minus 2, and then GCF here is minus 2, 3x minus 2 again. So subtract 2, 3x minus 2. Alright, so 3x minus 2 times 3x minus 2 are our factors. Equals 0. Set each equal to 0. We don't have to write it twice. Add 2, divide by 3. X equals 2/3. Does that check? 3 times 2/3. Does that equal 2 times the square root of 3 times 2/3? Subtract 1. Alright, 3 times 2/3 is 2. 3 times 2/3 is 2 here. Subtract 1 is 1. Square root of 1 is 1 times 2 is 2. It checks. So if there's a coefficient with the radical, we'll square the coefficient also. If there's a binomial on one side of the equal sign, you must multiply the binomial by itself. This is often forgotten. Let's look at H. Alright, so our square root, our radical, is isolated. It's by itself there, so we are going to square both sides. And yes, this is a binomial here, so make sure you are multiplying x plus 2 times x plus 2. And this removes the square root symbol. We get x squared plus 2x is plus 4x. So I combine the middle terms in one step. Right? 2x and 2x is 4x. Standard form, subtract 3x, subtract 16. And factor. Factors of negative 12 that sum to 1, positive 4 and negative 3. X equals negative 4 and x equals positive 3. Check. Does negative 4 plus 2 equal the square root of 3 times negative 4 plus 16. This is negative 2. Does that equal? There's no square root that's going to result in a negative 2. This is negative 12 plus 16 is 4. And the square root of 4 is 2. 2 equals negative 2. No. This is extraneous. Does not check. So negative 4 is an extraneous solution. And please write the word, we've seen that word used on the Regents exam, so you do have to know that what it means. The more you write it, the more it'll help you to remember. Checking 3. Is 3 plus 2 equal the square root of 3 times 3 plus 16? 5 equal 9 plus 16, 25. Yes, 5 equals 5. That checks. So our only solution is x equals 3. Okay, here with I, we've got to get this square root of 2x minus 8 by itself, so we subtract 4 from each side. Not that you have to show that. We have x minus 4 equals the square root of 2x minus 8. We'll square both sides. And again, make sure you're multiplying x minus 4 times x minus 4. A trinomial results. X squared minus 4x plus 16. The minus 4x and minus 4x is minus 8x. Standard form, subtract 2x, add 8. The factors of 24 that sum to negative 6. Let me go back, subtract 2x and add 8 would give me a negative 10x here. Okay, so the factors of 24 that sum to negative 10 are negative 6 and negative 4. We have x minus 6 times x minus 4 equals 0. X equals 6, x equals 4. And again, we must check into the original equation. So does 6 equal 4 plus the square root of 2 times 6 minus 8? 12 minus 8 is 4. The square root of 4 is 2. 4 plus 2 is 6. That does check. Does 4 check? Does 4 equal 4 plus the square root of 2 times 4 minus 8? Does 4 equal 4 plus, that's 8 minus 8, if the square root of 0 is 0. Yeah, 4 equals 4, that checks. So both of these are solutions. So the next page. If there are two radicals in an equation, arrange one on each side of the equal sign and square both sides. Alright, so for this one, that's what we have here. We will square both sides. That removes the square root symbol. 5x minus 3 equals x plus 13. This is linear, right? There's no x squared term, just x's, so subtract x, add 3, and divide by 4. X equals 4. And check in the original. is the square root of 5 times 4 minus 3 equal to the square root of 4 plus 13. That's 20, subtract 3 is 17, and that's 17. Yes, checks. Okay. All right, we want the square root on either side. So I'm going to take this and add it to the other side. So we have 2 square root of t plus 7 equals square root of t plus 25. Just adding square root of t plus 25 to both sides. Now square both sides. Make sure you square the 2. So we have 4 parentheses t plus 7 equals t plus 25. Distribute the 4, 4t plus 28. And this is linear, so subtract t and subtract 28. We get 3t equals negative 3. And divide by 3, t equals negative 1. Checking is 2 square root of negative 1 plus 7 subtract square root of negative 1 plus 25 equal to 0. So this is 2 square root of 6 minus the square root of 24. And I can simplify the square root of 24, right? I'm thinking 4 times 6, and the square root of 4 is 2. So 2 square root of 6. Yeah, so 2 square root of 6 subtract 2 square root of 6 is 0. So it does check. Okay, now you can attempt these on your own if you like. I'm just going to just say, okay, here you would raise both sides to the power of 3. Here you would square both sides. Subtract 2. And then go about squaring both sides. Same here, subtract 9. And then cube both sides. Square both sides. Here, bring the add 2 square root of x plus 4. And then square both sides. Off to the side, I'm just going to write the answers. Again, if you want, you can attempt these on your own. I'll use green. Answer to 1 is 3. 2 is 0 and 1/9. 3 is 80/3. 4 is 2. 5, 4, and negative 3. 6 and negative 2. Now the last, I do want to do number 7. Consider the system equation shown below. Solve this system graphically using the grid to the right. So we definitely use our graphing calculator for the square root of x plus 3. Look at the table of values. So we have a 6, 3, a 1, 2, a negative 2, 1, a negative 3, 0. Yeah, it's a square root function shifted 3 to the left. right? Yep, so square root functions shifted 3 to the left. Okay. -3, 0. -2, 1. 1, 2. And 6, 3. Right, our domain x is greater than or equal to -3. That's what we have, because we cannot take the square root of a negative number. Okay, y equals square root of x plus 3 is graphed. Y equals x plus 1. I'll use red for that. Y-intercept 1, slope is 1. Straight edge, do I have one? So the domain x is greater than or equal to -3. I think I might have said 0 before. For the domain here, x plus 3 has to be greater than or equal to 0, so x has to be greater than or equal to -3. Okay, so solved graphically, we have one solution. That is zero, 2. I mean 1, 2. Sorry. Now, solving algebraically, okay, so we'll set the two equal to each other and solve for x. Square both sides to get rid of the square root. X plus 3 equals x plus 1 times x plus 1. That's x squared plus 1x plus 1x is 2x. Standard form. Subtract x and subtract 3. And factors of -2 that sum to +1 are +2, -1. So x equals -2 and x equals +1. Now we would check, right? -2 into, well, our original here is -2 plus 3 equal -2 plus 1. The square root of 1 is 1. Does that equal -1? No. So this is extraneous. Does 1 check? Square root of 1 plus 3 equal 1 plus 1? Yeah, the square root of 4 is 2. 2 equals 2, yes. So once we have the value 1 for x, then we find the value for y. Y is equal to 1 plus 1, which is 2. So 1 comma 2 is our solution. Why does our answer from part A contradict what we found in part B? Oh, because squaring it introduced, solving it algebraically, and squaring both sides introduced an extraneous solution. Okay, and for part B, I apologize. It said for only the x values. Right, for only the x values. So our answer is x equals 1. Once again, I thank you for your attention.